The next objective is to calculate or perform a chi-squared test for independence. And this is our third and final chi-squared test that we'll learn. We learned goodness of fit, chi-squared test of homogeneity, and then this is the chi-squared test for independence. The chi-squared test for independence is actually, it's almost the exact same process as the homogeneity test. The only difference is how the data was collected. And more on that after I go through this problem. But the key thing to think about here is a test for independence is we're looking for an association, or if there is an association between two categorical variables from one population of interest. So the previous test we ran, we took 3 samples from 3 different populations to see if their distributions were the same or if there was a difference in the distributions. Here we're looking to see if there is an association between some categorical variables. So the first thing you need to be thinking about is if it's ever asking you if there's an association, you should think it's a chi-square test for independence. Or if they ask you something like, are the variables independent, then that also is a good sign that it's going to be a test for independence and not the test of homogeneity. But you'll see it's the same process as the homogeneity test. So let's look at an example here. Are people who are prone to sudden anger more likely to develop heart disease? An observational study followed a random sample of 8,474 people with normal blood pressure for about 4 years. Each person took the Spielberg trait anger scale test. Researchers also recorded whether each individual developed coronary heart disease. Do these data provide convincing evidence of an association between variables in the larger population? So there you go. It's an association, so it means we're doing a test of independence. So the first thing I'll do is, well, I guess look at the table here and just familiarize myself with it. This has 2 rows and 3 columns. And so I'm looking for an association between coronary heart disease and their anger level. So in the state section, let's write out our hypotheses. Our null hypothesis is that there is no association between anger level and heart disease status in the population of people with normal blood pressure. And we can only say this about people with normal blood pressure because that's who was involved in this observational study. The alternative is that there is an association between anger level and the heart disease status of the population of people with normal blood pressure. So I also want to list what level of, or what alpha level I want to have here. So they haven't given me one. I'll use an alpha level of 0.05. And then we'll move on to the plan section where we will check the conditions and state the type of inference. So this is a chi-squared test of independence for independence. One more thing about the hypotheses before I move on to the plan section. It's also okay to say, for instance, the null hypothesis, I could say that anger and heart disease status are independent in the population of people with normal blood pressure. So independent or no association, they both mean the same thing, just worded a little differently. So first I'll check the random condition here. And the random condition, they told us that it was a random sample taken from the population. So this is really the key difference for a test of homogeneity and a test of independence. We took one sample from one population here, and it was a random sample. For a test for homogeneity, we're going to take samples from different populations or compare groups from different populations. So in this case, they told us it was a random sample, so we're good to move. Next, the 10% condition. Our sample size is 8,474 people. And it's safe to assume that this is less than 10% of all people who have normal blood pressure. So the 10% condition is met. The large counts condition is where I have to make sure all expected counts are at least 5. So I'll do that on the calculator, but just a reminder, we're going to do the row total, 190, times the column total, 3,110, divided by the table total, and that will give me the expected counts for this first cell. Second way, type these in your calculator and it will calculate it for you. That's the way I'm going to do it. So go to my matrix, second, x to the negative first, and I need to scroll over to edit. And my matrix is a 2x3 because I had 2 rows and 3 columns. So now I'll type in the data. Once I have them all in, excluding totals, of course, then I can do stat tests. And I'm going to actually do the exact same chi-square test that I did for a test of homogeneity. But this is for a test of independence. It's just the same function on the calculator. Table A or matrix A is the observed values. It will put the expected values in B. So I'll hit calculate, and I'll go ahead and copy the chi-square test statistic, p-value, and degrees of freedom onto the notes. But notice the p-value is not 3.228. It's got this e to the negative fourth, so it's 0.0003228. So it's a small p-value here. I'll copy this to the notes, and I'll also go to matrix B where the expected values are. So hit second matrix, and then over to edit just so I can see what it is, matrix B. Here are my expected values. So I need to copy this onto the notes as well. As you can see, I've copied over the expected counts, and you have to actually copy these over in a chart like this and show that each of them are greater than 5. And that satisfies the large counts condition. And I've also copied over my chi-square test statistic, 16.076. My p-value was 0.000323. Degrees of freedom was 2. Remember, that's row total minus 1 times column total minus 1. And I can use this now to draw my conclusion about the test. In conclusion, since our p-value is less than our alpha level, we have convincing evidence that there is an association between anger level and heart disease status in the population of people with normal blood pressure. So this is just a reminder that when your calculator tells you your p-value is, like it did for me, 3 point something, you need to make sure a p-value can't be greater than 1. P-value is a probability, so it's a value between 0 and 1. So you need to make sure you've gotten your p-value written down correctly.